FFBDs have the classic features of logic structure and control flow, and are available for elements in the function class. They unambiguously represent the flow of control through sequencing of functions and constructs, focusing exclusively on structural control and ignoring the sequencing and synchronization aspects of the corresponding data flow. The EFFBD is the most complete representation of behavior. It includes all of the flow and sequencing information from the FFBD, as well as the data interactions, overlaid to present a more complete picture. EFFBDs also display resources, the third critical aspect of executable behavior. Rectangular nodes represent functions. The flow of control is left to right. Circular nodes and branching structures represent control constructs, the building blocks of behavior. As a function completes execution, flow of control proceeds along the branch lines to the next function or control construct. A special aspect of FFBD and EFFBD representations in GENESYS are reference nodes. Reference nodes reflect the context immediately surrounding this behavior. The function shown in a gray box with a broken frame on the left edge represents the last function to complete before this decomposition begins, the source of control flow. The function shown in a gray box with a broken frame on the right edge represents the next function to enable when this decomposition completes, the sink of control flow. When there is no previous or next functions, the boxes are simply labeled ref. These reference nodes are automatically computed and updated by GENESYS and provide very valuable context information. Each construct has a precise definition that prescribes how control will be passed within the construct and when the construct itself will end. Let's take a moment to overview what each of these constructs does. First up is the AND construct, also called a concurrency or parallel. The AND node is followed by separate branches that rejoin and terminate at another matching AND node. The construct designates that all branches execute concurrently. Further, all branches must complete before execution can exit the AND construct. The OR construct is also called a select construct. When execution reaches this construct, one of the branches is chosen and executed. None of the other branches are executed. Each branch can be assigned a selection probability using the right-click menu. A multi-exit function is a construct where multiple branches exit from a function and rejoin at an OR node. This operates similar to an OR construct where only one of the branches is executed. When an exit node is encountered, the rest of the diagram is skipped, and execution will move to the sync reference block. A loop construct consists of a pair of loop nodes that enclose a branch and are connected with a loopback line. Everything between the loops will be repeatedly executed in sequence. A loop is usually accompanied by a loop exit, which provides the mechanism for exiting a loop. Without an exit, the loop continuously executes. When a loop exit is encountered, the innermost loop is immediately terminated, enabling the construct or function following the loop. An iterate construct consists of a pair of nodes that enclose a branch and are connected by a loopback line. The line is automatically labeled with the name of the associated domain set element. Everything between the iterates will be executed in sequence, the number of times defined by the domain set count attribute. A replicate consists of a pair of nodes that enclose a main branch and are connected with a coordination branch. This coordination branch is automatically labeled with the name of the associated domain set element. The replicate construct is a shorthand notation for identical processes that operate in parallel. All of the constructs we just defined are used in both FFBDs and EFFBDs. Let's discuss ways in which the EFFBD is unique. The EFFBD displays items as they are passed between functions. Items are output from, input to, or trigger functions. Inputs are data store items that have nothing to do with the control of the model. They simply represent data that one function outputs and another function receives as inputs. This figure shows a data store that is output, then input. Notice the single-headed arrow as the item is received by the second function. When an item is required to be received by a function in order for the function to execute, this item is called a trigger. By default, a trigger item will be colored green. You can also identify it by the double-headed arrow as the item is received by the second function. Resources can be produced, consumed, or captured by a function. These are represented on an EFFBD similar to an item with a second ring around it. If the flow of control has reached a function, but either the triggers or resources are not available, the function is said to be enabled, but waiting. Resources are an advanced concept that we can't fully detail in this video. Reference the Simulation User Guide for full details. Remember that the real value of modeling your behavior in an EFFBD is realized through exercising that model. The Simulation User Guide will help you learn to use the simulator, where you can examine your model to ensure it performs as desired.